Hi there, this is question 17 from the June 2012 Unit 3 Edexcel maths paper, and we're looking at two cones. It gives you the diameters of the cones, and it's asking us in the first part to work out how much paint will be needed to paint the second cone B, and it tells us how much is in A. So let's have a look at the key information and see what we can get sorted on this one. So key information wise, we've got two solid cones made from the same type of metal. The two solid cones are mathematically similar. There's the first key bit, and that actually gives away the approach that's needed for this question. I'll come back to that in a moment. It tells us the diameter of the two cones, and they're important. It tells us how much paint it would need to cover cone A, and then we're working out how much paint we'll need to do cone B. Now, a moment ago I said that mathematically similar is key. Initially you could look at this question and it talks about how much paint we need, and it talks about a volume, and you could go to your formula sheet and look at the third pi r squared h and think that we're going to be working out volumes, but actually we don't. And the reason we don't is this bit here. Where it tells us it's mathematically similar, that means that we're working with scale factors. And what we've been given is information to tell us the length scale factor. Now the length scale factor between the two shapes is 2, because B has twice the diameter of A. So the length scale factor is 2 because B is twice as big as A. However, the area of the shapes is not twice as big. Because we're now working in 2 dimensions, the area scale factor will be 2 squared, which is 4. So the length scale factor squared, and that means that any area on A will be 4 times as large on B. Equally, for the volume scale factor, hopefully you can spot where this is going. Just make sure you have a think about what you think I'm about to write. And actually it's the length scale factor cubed, because we're now dealing with 3 dimensions for volume, which means any volume will be 8 times as large. So let's see how we can apply that to the question. The paint needs to cover essentially the surface area of A. So for this one we're going to be dealing with the area scale factor. And the area scale factor is 4. So if it takes 80 millilitres of paint to cover the surface area of A, then what we're going to need to do is take that 80 millilitres and times it by 4, because the area we're trying to paint is 4 times larger. And that gives us 320 millilitres. For part B, it tells us the volume of A. So inevitably now we're going to be dealing with the volume scale factor, and because B was twice as large as A, and the volume scale factor will be 2 to the power of 3, so actually the volume is 8 times larger inside that cone B than it is in cone A. So what we need to do is take the volume of A and times it by 8, and that gives us 1,373,600 centimetres cubed. The key thing to this is that it says mathematically similar, which means you have to deal with scale factors. If you know the length scale factor, you can work out the area scale factor by squaring it, and the volume scale factor by cubing the length scale factor. In some more tricky questions, they might give you an area scale factor, in which case you'll have to square root it to find the length scale factor. Feel free to investigate this more if you feel that you need a bit more time, and maybe you come back to this question and see if you can understand it after doing a bit more practice. Thank you for your time. I hope this proved useful.